Hello, I am Peter, and I will be guiding you through this module on different mathematical tools regularly used in financial analysis. This time, let's talk a little about skewness, a measure that gauges the bias or degree of symmetry in the distribution of data in a series of values. Specifically, skewness quantifies how much the data distribution deviates from a normal distribution. When skewness is positive, the right tail of the distribution is longer or heavier than the left tail. In this case, outliers tend to be greater than the mean. When skewness is negative, the left tail of the distribution is longer or heavier than the right tail. Here, outliers tend to be less than the mean. In this video, I want to focus on the steps necessary to calculate this important measure. Let's get started. We will perform the calculation step by step using Excel. The first step is to calculate the average return. This average return is the result of adding all the monthly returns and dividing by the number of months of data. We can also interpret it as the return we predict for each of these firms looking forward. After calculating it, this return is 2.67% for TTI. Once you have the average return for TTI, you can now calculate the variance and the standard deviation of its returns. Remember that we performed these calculations step by step in one of the previous videos on standard deviation. Just to refresh your memory, we need to calculate the deviation of the return for each month from the average return. These deviations must then each be squared. Finally, remember that the average of these squared deviations is the variance and the square root of the variance is the standard deviation. You can verify that your answers are correct using the Excel commands var.p and stdev.p. As the third step to calculate skewness, we need to cube the deviation of the return from the average return for each month. Then, we sum these deviations raised to the third power. In this case, this sum equals 0.00003. This is the numerator of our fraction to calculate skewness. The fourth step is to determine the denominator of the skewness formula. This is simple. You just need to cube the standard deviation and then multiply it by the number of observations. In this case, the result is 0.004%. Finally, we just need to divide the sum of the deviations raised to the third power, which is 0.00003, by the denominator of 0.004%. The result is negative 0.86, which is the skewness. One last reminder is that you can verify your calculations by using the skew.p command. Thank you for your attention and for the great work you've been doing. Let's stay in touch.